got 2 carbons, 6 hydrogens plus 2 is 8 hydrogens, 4 hydrogens plus 4 hydrogens, 8 hydrogens, 2 oxygens, 2 oxygens. This is neutral for net charge. This is neutral, this is plus 4 altogether, plus minus 4, 0. So it's balanced. This is good. That's how you check it, your answer. Just make sure it's balanced. Did you add them up already? Okay, once we get this, then we add up. This is a half reaction. This is a half reaction here. Once we get the 2 half reactions, then we combine them. But this is good because 4 electrons are consumed here. 4 electrons are produced here, so the electrons are already balanced. We don't have to multiply by any coefficient. But anyway, the steps here would be, we could just figure this out. We're missing an oxygen here, so we'll just do plus of water here. And then we total up the hydrogens. 6 plus 2 is 8 hydrogens. 3 plus 1 is 4 hydrogens. So we add 4 H pluses. And then we do the charge. This is 0, 0. This is 0 plus 4. So it's plus 4. We make the charges equal by neutralizing positive charges by adding electrons. So we'll just add 4 electrons here. We'll make it 0 and 0. We add these up. We get that equation there. So that checks out. Now we'll add both half reactions. So we'll add everything on the left. We don't have to multiply it by anything, fortunately. So CH3, CH2OH plus H2O there. And then over here, add up everything on the left. O2 plus 4H pluses plus 4 electrons will cancel. This is going to produce CH3COOH plus 4H plus 2H2O. Then we simplify. Here's an H2O here. We can eliminate one of these 2 here. Then we have 4H pluses here. We can eliminate those 4H pluses there. And so the net reaction for this is CH3CH2OH plus O2 yields CH3COOH plus water. So did people get stuck on this here? The steps here?
What was it, 2 waters on the right side?
Oh, those 2 waters came from this.
Oh.
So I add up everything on the I'm adding this equation with that equation. So everything on the left of that equation plus everything on the left of this equation. Everything on the right of that equation plus everything on the right of this equation. So that's where the 2 waters came from. So this is what happened. We could also look at the driving force as well. You know, this is our oxidizer here. This is our conjugate reducer here. This is our reducer here. This is our conjugate oxidizer here. And so this is our reducing. This is our reducing agent. We need the H pluses and other stuff in there, but essentially this is it. This is our reducing agent. This is our oxidizing agent. Then acetic acid will be our oxidizing agent. This will be our reducing agent going backwards with water. So we look, what's a better oxidizing agent? Oxygen or acetic acid? Well, it's not on the chart, but what would your guess be? What would be a better oxidizer, oxygen or acetic acid? Oxygen. Stronger. What would your guess be? What would be more flammable, ethanol or water? What would be with ethanol? So this is stronger, this is weaker. So we are going to have driving force for this. All right, that's the skeleton redox. I wanted you guys to finish it, everybody, but I'm a bit behind, so I need to. No, it doesn't matter.
Oh, okay.
You could write it any way you want. Oxidizer first, reducer first. This is random. There's no convention. For batteries, there is a convention. This is one where we're going to get to at the end of the semester. At the end of the semester, you put your reducing agent first in a battery, and then your oxidizing agent second. And so all batteries are written like this here. The reducing agent is over here, the oxidizing agent is over here. That's by convention, but you don't have to follow any convention. If you look at the equation they wrote just the opposite. The equation, they wrote the oxidizing agent here and the reducing agent second. And the battery itself, the reducing agent came first, and the oxidizing agent. All right, I spent a lot of time on chemical reactions because, you know, this class is chemistry, and you're supposed to learn some chemistry rather than just the math and the physics. And so, I want to talk, like, for example, what are the chemical properties of certain things? And so, let's look at something like HCl. What are the chemical properties of HCl? It's a strong acid. That's good. Strong acid. What else? Yeah, it'll react. What will HCl? It's a strong acid, so what else could you say about HCl? Is that it? So this is why I spend a little extra time on chemical reactions, because the book doesn't present it in a systematic way. You know, if I wanted to know the chemical properties, the first thing I'd look for are metathesis properties. For example, you know, what ions does H plus like? What ions does Cl minus like? Well, H plus, this is an acid, so we'll cover this in the acid section here. But we could cover it now as well by looking at the chart. Basically, the driving forces for metathesis, when we're dealing with an acid, the driving force is what? Stronger to weaker acid. So if we start here, this is H plus, right? And this is the way we can use the chart to rapidly determine this. If we start here at H plus, and let's say we react with this base, nitrate, what acid would we form? If we take H plus and nitrate, we would form what? Nitric acid. Is nitric acid a stronger or weaker acid? It's a stronger, so we're going from weaker to stronger. If we take H plus and react it with chlorate, we'd form, what's this called? Chloric acid. Is chloric acid a stronger acid or weaker acid than H plus? Stronger acid. So do you see, no matter which of these bases here I reacted, I'm going to form a stronger acid. So we're going from weaker acid to stronger acid. Is that favorable? No, we'd say no reaction, right? However, if I take H plus and react it with this, or actually let's go with this. If I take H plus and react it with sulfate, what would I form? I'd form, this is Bronsted, I should talk about these in Bronsted. But what I'd form is hydrogen sulfate. Now, is hydrogen sulfate or bisulfate weaker or stronger? That's weaker. And so H plus will react with all bases that are stronger than water. All these bases. Okay, let me ask you this as a follow-up question. As a follow-up question, will phosphoric acid react with all bases stronger than water? Is that true or false? Phosphoric acid will react with all bases stronger than water. That's false. That's false. How can I make it true? I can make it true by saying this. Phosphoric acid will react with all bases stronger than dihydrogen phosphate. Then it will be true. The reason for that is this. If I take phosphoric acid and react it with sulfate, I'm going to go from phosphoric acid, reacting with sulfate, I'm going to form hydrogen sulfate. And I compare hydrogen sulfate versus phosphoric acid. Well, hydrogen sulfate's stronger, so I'm forming a stronger acid as a product. And so the phosphoric acid will not react with any bases weaker than this. The only case is it'll react with bases that are stronger. So for example, if I take phosphoric acid and react with nitrite, I'd form nitrous acid. Well, nitrous acid is weaker than phosphoric acid, therefore there's driving force. Do you see that? So phosphoric acid reacts with all bases stronger than this. So yes, it's a strong acid. Well, what bases does it react with? Well, it reacts with all bases stronger than water. What about chloride? What does chloride like? Chloride's a base, but as far as the base goes, it's too weak. Remember? Chloride's too weak to be a base. Think table salt. Is table salt a good base? No. But in terms of metathesis, what cations does chloride like? Well, chloride reacts with silver, lead, and mercury. And so chloride will react with anything that contains silver ions, lead ions, and mercury ions, mercury 1. It likes those because it'll form precipitates. All the other ions it doesn't react with. For example, iron 2. Does chloride react with iron 2? No. Iron 3, no. There's a whole bunch of no reactions, but the only 3 species that will react with are these. And so if I have silver acetate, yes, it will react. If I have silver nitrate, yes, it will react. If I have silver chlorate, yes, it will react. Because it contains silver on it. Does it make sense? Then we go to acid base. You know, H plus is an acid. Chloride is a base, but it's too weak. Too weak to be considered a base in water. So H plus is the acid. This will react with all bases stronger than water. So it's just a repeat of metathesis here. And then we go to redox. In redox, H plus is what we call an oxidizing agent. This is how we use the chart rapidly here. H plus is an oxidizing agent. Well, what will H plus oxidize? Well, it's going to oxidize reducing agents. So here we have H plus. Will H plus oxidize tin 2? If H plus oxidizes tin 2, then tin 2 loses electrons and gets converted to tin 4. And so we're going from tin 2 to tin 4. Do you see that? So H plus reacts with tin 2, converts it to tin 4. Then we compare the two oxidizers, H plus versus tin 4. Which one's stronger? Tin 4 is stronger. So we're going from a weaker oxidizer to a stronger oxidizer. Is that favorable? No. And so what we should say is that H plus will oxidize any reducing agent stronger than hydrogen. So, for example, if H plus reacts with hydrogen, then we're just going to form hydrogen and H plus, so there's no reaction there. And so we need something stronger than hydrogen. So H plus reacts with lead. If H plus reacts with lead, then lead gets converted to lead 2. Now compare the two oxidizers. H plus is stronger, lead is weaker, and therefore is this driving force. So what we can say is that H plus will react with lead, tin, iron, zinc, aluminum, magnesium, sodium, calcium, potassium, lithium, but H plus will not react with tin 2, copper, silver, gold, platinum, etc. Ones that are weaker. So H plus reacts with all reducing agents stronger than hydrogen. H2. Chloride is a reducing agent. What will chloride react with? You tell me. Look at the chart and tell me all the species. Name them. Name all the species you can think of that will oxidize chloride. Tell me all the species that will react with chloride, oxidize chloride. For example, will dichromate oxidize chloride? Okay, from this one, we do this. We go chloride reacts with dichromate. What does it form? If chloride reacts with dichromate, it's going to form chromium 3. Which one's a better reducer, chromium 3 or chloride? Chromium 3 is better. So we're going from a weaker reducer to a stronger reducer. Is that favorable? No. Then we go the opposite direction. If I take chloride and react it with permanganate, we'll form manganese 2. Now let's compare the two reducers. Chloride versus manganese 2, which one's stronger? Chloride's stronger, so we're going from stronger to weaker. Is that favorable? Yeah. And so tell me all the species chloride will react with. Chloride will react with what I mean by tell me all the species. Fluorine. Will it react with fluorine? Yeah, because if chloride reacts with fluorine, we form fluoride. Fluoride's much weaker than chloride. So we're going from stronger to weaker, right? Will it react with ozone? Will it react with S2O8 2-? Will it react with hydrogen peroxide? Yes. Will it react with permanganate? Yes. Will it react with lead 4 oxide? Will it react with chlorine? Well, we get no reaction. And so chlorine with chloride is going to form chlorine and chloride, so this is NR. Will it react with dichromate? No. And so what we say is that chloride is a reducing agent. It reacts with oxidizers. It reacts with all oxidizers stronger than what? Stronger than chlorine. So do you see, these are the chemical properties of HCl here. It participates in all 3 types of reactions: metathesis, acid-base, and redox. I went overtime again, so I'm going to stop here.